Hi everyone. From what I understand, there's a varied levels of experience among people here. So as Nina already explained, um, we teach basics of neuroscience and basics of Python here. Not quite to the level where you can be a scientist, but enough to understand the fundamentals in both so that you can see the overlaps and have a good idea of where to go next, and maybe possibly help you with a direction or even to just get those first fundamental steps into the game. Now, I will mostly be focusing on teaching the Python side of it. I will also focus a little bit on neuroscience, but yeah, mostly my role here will be in Python capacity. And Nina and Muhammad will be more focused on teaching the neuroscience aspect. So roughly, yeah, I'm not sure if I'm repeating Nina here, but yeah, so we'll start out. I'll just tell you briefly what we're going to do. We'll start with basics of programming, like why even do it, what it is, and what can we do with it, and so on. We'll go into how to just interact with a normal screen, just get results printed on it, get user input. We'll go into what's a variable, what's functions, what's conditionals, what's loops, and just we'll go through every main concept you need to understand in programming, regardless of which programming language you choose. And then by the end, on programming side, we will see how this relates at all to neuroscience and what programming lets us do in that field. And in fact, we will also experiment a little ourselves. So let me see. So the thing is, um, there are certain areas of neuroscience where you have to be able to program as well because it's more like neurotechnology than just science. So such areas include just creating prosthetics for people. Like let's say someone loses an arm, but they want to move a new prosthetic robot arm and they want it to be intuitive and detailed. Sometimes what we might do is that we know that from our brain we have to send the signal that goes all the way to the muscle. So we try to catch that signal, make sense out of it, and then instruct the robot arm to move the same way as you would a normal hand. So that's one example where you have to program this device to understand the signal and figure out, did I want to move this finger or this finger? Did I want to close my fist maybe, or did I want to open it perhaps? And for that kind of stuff, we need programming. So that's one area. Another area where programming is relevant for neuroscience is when we want to analyze, like for instance, let's say we want to figure out if there's some early markers for schizophrenia, for instance, let's say. So what we might do is we might want to analyze the brain patterns of 1,000 healthy individuals and 1,000 individuals who have, let's say, different stages or different forms of schizophrenia. And then we might try to compare and see if there's some pattern we can detect from which we would be able to tell, this pattern, maybe if detected earlier, could detect that problem early, or maybe like something like that. So that's also one thing we might use programming for in neuroscience. And also another thing that you might have heard of, rather a relatively recent one, is, for instance, with companies like Neuralink from Elon Musk, where they try to basically upgrade humans' abilities to communicate. So what they did so far for 12 people is that so for people who are completely paralyzed, quadriplegic, so they cannot move their arms or legs at all, but they can still speak, but like that's all they do, neck down, they're paralyzed. Communications are quite difficult for them. So what they did was they insert a chip in motor cortex of a brain. We'll discuss what motor cortex is tomorrow. And basically, they insert a chip in a person's brain, and from this, they can figure out, oh, this guy wanted to move his index finger, this guy wanted to do this, or that movement, or this movement. And from this, they will map this to keyboard and mouse so that those people can now telepathically control their computers. So they can like type, they can even play video games, and just anything we can do with computers, they can also do. So that way, they can now just be a functioning member of society again. They can even have a job or just have fun. And it's just one step toward, let's just say, bringing back the capability they lost because of paralysis, and also even potentially giving them new abilities that no current person has. Like, for instance, one strange thing we found is that these paralyzed people who got the chip implant can now telepathically write text faster than any human can type with hands. Another interesting thing we find is that there are not exactly defined limits on what can be achieved eventually with these kinds of technologies. So, for instance, right now there are tests being conducted to see if we can cure blindness that way. Because, for instance, we know that the way our vision works, and don't worry, you're not expected to know this, we'll go through this in detail, but roughly, the way our vision works is that light hits our eye focuses on the inside. On the inside, we have neurons that basically react to light. They send out a signal in our brain, in a place in our brain called the thalamus, and from there, the light gets all the way to the back of our heads. And the back of our head has a visual cortex where we basically make sense of what we saw, which is that is where we realize, oh, I must be looking at my computer, I must be looking at my friend, I must be looking at color red. And people who are blind because either their eye is not working well or the nerve that's supposed to carry the information from their eye to their visual cortex is damaged in some way. So some new works are just trying to see if we can get a camera so that it records the light just as our eyes do, and then take this signal and directly send it to the visual cortex. That way, regardless of if your eye is damaged or if your optic nerve is damaged, you can still regain the ability to see. And at first, it's expected to be very low quality, like you can just barely tell apart if someone is standing in front of you or not, but you can't tell who. But then over time, it's expected to get better, and eventually, we might even, not might, we will basically gain new abilities. For example, right now we can see red, green, and blue and mixtures of those colors, but there are colors that we can't see, yet we know they exist. For instance, we can't see infrared light, which is also heat vision, if you know. There is also ultraviolet light that we can't see, and there are also X-rays and just other frequencies of light that human eye cannot see. But with these kinds of prosthetics that are at first developed for blind people, but eventually for potentially anyone, we would still be able to see normal colors and new ones as well. So just generally, for the most part, neuroscience research focuses on just helping people with disabilities to manage their life better, maybe even gain some capabilities back, or at least somehow replace them with some new ways to still communicate, still move, and still do things. But also, basically, the new emerging thing is that we might even augment humans to new levels. Like potentially, even we might be able to upgrade humans' ability to focus, or human intelligence, or just rate at which we can learn things, or just nearly anything eventually is possible. So that is why I think that this field is exciting, because what we're talking about here is that eventually down the line, we might develop ways with which we could even become as much smarter than just baseline what we were like today, then just as much of a difference as today between us and like monkeys or some other animals. So I don't know if this might sound a little strange, but yeah, basically there's a lot of interesting things we can do with neuroscience, starting from even curing paralysis potentially to let people walk again, or making sure that they can control prosthetics properly, to even just enhancing our focus, our moods, and just intelligence even. There's also some strange potentials of unlocking new kinds of senses and unlocking even possibly control of multiple robot bodies and such, but it'll take us far to go there. We'll go back into the topic of what this can be used for at the last lecture when we discuss devices. Yes, Roy, you can rejoin as you feel. Don't worry, this is a recording, so you can watch. But yeah, I won't start the coding part for the next 3 minutes. I'll just talk motivation for now. Okay, so that was my main idea of just what we can do with it. And yeah, so basically we can heal people with it better. We can augment the existing capabilities. And obviously also we need programming and neuroscience to understand ourselves better. So that means we might understand, for instance, how depression works, how anxiety works, and how we can treat them better. Maybe we can figure out some new lifestyle habits that everyone should be doing. Like, for instance, we know that in the morning, if you face sunlight, you'll be in a better mood and better energized. These kinds of things are also from neuroscience studies. We might also discover how to, for instance, cure chronic pains, nightmares, PTSD, and all kinds of things. But yeah, in my opinion, the main things is that we can understand what it means to be human, like on a deep sense, what it means to be conscious, even, and what we can do in the world. What can we enhance? What can we fix? What can we augment? Yeah, just all of it. Now, there are many ways this can be done. There are many devices we can use to, for instance, measure what's going on inside our minds and from that figure out, oh, so this is how someone is lying. Maybe we can make a better lie detector. Or, oh, this is how we think of moving our pinky. Maybe that way, every time I think about moving my pinky, I could map that thought to some action. And yeah, just a lot of capabilities we can unlock that way, is what I mean. For instance, also one recent one that we should mention is Meta a few days ago released this smart glasses, which they eventually want to replace smartphones completely. So in their vision, and I guess I agree with this, in a couple of years, people will not really be using like iPhones and just smartphones at all. Instead, everyone will probably be using some kind of smart glasses because they'll be a lot more comfortable. Like with a phone, you have to pick it up, put it in front of you, then you have to type on it, you have to use your hands. It's just very slow process compared to what can be done. And what can be done is that first, even today, what you can already buy for $800 from Meta is that you wear smart glasses that display on screen and can talk to you. And you can also talk to it, and it's an AI, very Meta Llama, that will respond to your questions. And you can also get it to like take pictures, take videos, whatever. And most interestingly, you can control it using your hand, but just by leaving your hand like this and by wearing a bracelet, which will detect what movements you are intending to make, just slight movements. And from that, it can just allow you control. And this means that you won't actually have to wait for your muscles to move. So you'll be able to become way faster and it will just be a more comfortable experience. Eventually, I'm thinking maybe you won't have to move your hand at all and you'll just think about it. And that's potentially also possible. So basically, in the coming eras, we will see more and more of the world going to brain-computer interfaces, where we connect our mind directly to the world. Like, if you think about it, right now, the only ways we pretty much interact with the world is through our senses, from which we find out things about the world. Like from my sense of touch, I know that I am sitting. From my sense of temperature, I know if this room is too cold or too hot or anything like that. From my sense of sight, I can tell that I am on this lecture because I can see it. And yeah, we have hearing and so on. So these are the senses with which we see the world. And we interact with the world through our muscles. So everything that we do through our motor neurons, is how they're called. So what does that mean? We want to use devices or just talk to people. We have to move our hands, move our legs, move our fingers, or even when we speak, we have to move our tongue, our throat, and so on, so that we can produce the correct sounds. So right now, we are limited by the speed of our muscles in communication because you can only type something or say something at whatever speed your muscles can move it. But when we go into telepathic communication, which is just taking signals straight from your brain and mapping that to devices or whatever, we'll just be able to get 100 times, maybe 1,000 or million times faster. Eventually down the line, that might also mean faster comprehension and such that maybe you'll be able to read like 100-page book in a minute or things like that. That's a little bit farther in the future, but basically all of the groundwork we need to lay for that is happening right now, and that requires a lot of neuroscience and programming. And programming can break down into creating new AIs, just data science, just visualizing the data so we can make sense of it, and so on. We'll dive deeper into what kinds of programming are used in neuroscience in our last lecture. But yeah, for now, the rest of our programming related lectures will be just the basics of how to use Python and how to use programming, because we need to understand these fundamentals before we can contribute to any real extent in the world. Now, just one thing I want to mention is that obviously in the real world, we already have things like ChatGPT, Gemini, Grok, and just all the other large language models. And they are very useful. Like we should use them in real world. And in fact, in real work situations, people already do use them. But thing is, they are not quite good enough, and for many years still, they might not be good enough to just do everything on their own. They still need guidance and supervision, and you still need to interact with them and make sure that what they did is correct and they didn't miss anything. So for that, you still need to understand the fundamentals. Which is why here in this course, I still want to focus on fundamentals of programming at first without the usage of AI, so that even if you do use AI to write your code in the future, you should still be able to look at it and see, no, actually there's a mistake here, or this should be different a little bit like that, and so on. So yeah, so as you know, every week we'll have two lectures. One lecture will be about programming fundamentals, and the other will be about neuroscience fundamentals. And then in the last week, we will have two lectures that will both be about brain-computer interfaces. Hira, let me answer that. So he asked, by the way, yeah, okay. Do you think that AI integration in programming is useful and how you use it in advanced programming? Yes, AI integration is very useful and in fact absolutely necessary. Like, here's what I mean. When you said okay, there's different kinds of what you can mean by AI integration, but let me just make an example. So, for instance, remember earlier when I said that we might try to take signals that I was sending to my hand so that I can use this to control my mouse or computer instead? So that is something that we would use an AI for. And here's what I mean. We will take many examples of what my signals look like when I'm moving my index finger, I'm sorry, this is index finger, what my signals look like when I'm moving my pinky and so on. And then I will give this signal, a lot of signal data to an AI and tell it, look, this is what it looks like when I'm moving this finger. This is what it looks like when I'm moving this finger. Now figure it out and in the future, predict which finger I was intending to move. So what that means is that some of the code you would have to write yourself still, but for some parts of the logic, you can basically offload it to an AI. And I will discuss it a little bit in detail when we get to the last lecture, because that's when we will get into actual brain-computer interfaces, like how these devices work and where AI is relevant. But for the first lectures, I just want to focus on what the fundamentals of programming itself are. Okay. Did that
Okay,
answer
thank
your
you.
question? Well,
Yeah, this was my question. Thank you.
okay. Yeah, no worries. So, by the way, I encourage all of you to just ask as many questions as you get. In fact, this is good. In fact, one thing to keep in mind is that maybe you get a question and you're too shy to ask it, but consider this. Some of the other people might also have that question and they might also be too shy to ask. And so if you ask it, you can be helping a lot of other students as well. So please, I encourage everyone to ask questions. All right. So basically, I just want to say, yeah, what is programming? Programming means that we create some instructions that a computer will follow. Now, fundamentally, if you think about it, that means that uh, we give a computer some task and we want the task to be completed according to these steps. So the steps that the programmers take are called an algorithm. Uh, the way this works is that algorithm is just any instructions you can formalize so that any program can just go through it and say, okay, I'll do this, then I'll do this, then I'll do this, and so on. Like, for example, let's say that we want to, I don't know, bake a pizza. We might say that the algorithm to bake a pizza is to first get some dough, I don't know, maybe buy some tomatoes and just buy the ingredients. Then maybe next step would be to cut these tomatoes. Then the next step might be to just assemble the pizza, The next step might be to put it in the oven, then maybe wait 20 minutes. Then the next step will be to take it out, then again wait 10 minutes for it to cool down. And then the last step will be to cut it and eat it. So just anytime you formalize steps that you should take to accomplish a task, that's an algorithm. So I want you to be comfortable with this word. Here's how it's spelled. Algorithm. And by the way, all of you, I encourage you to sometimes check the chat as well. And I will also be checking it, of course. Yeah. All right. So the main ideas. We are using algorithms to just write any kind of logic in code. And now here's something interesting to keep in mind about AI and programming before we dive deeper. Aman, by the way, everyone, Aman is asking, do you think AI generated code can be trusted in critical applications and problems? Well, I think that without human reviewing it, absolutely not. But in reality, already, AI already writes a lot of the code, like even half of the code maybe, but a human has to review it and to make sure that there's nothing missing or problematic about it. So you still have to understand programming. So uh, critical applications would be just pretty much any application, really. Like if you're writing code for a bank, you have to make sure that you're transferring the correct amount of money to people, or else you get into legal trouble. If you're writing code for a hospital robot, you have to make sure that it works right, or else if it makes a mistake, it might kill a person. Similarly, if you're writing a code for, let's say, a self-driving car, if you make a mistake in there, the car might crash and kill people. And of course, similarly for planes, rockets, and just many systems where a mistake might mean, in best case, just losing money. In the worst case, some kind of legal trouble. But in worst case, the mistake might even kill people. So yeah, critical applications exist, of course. And AI is already used in probably all of them, or at least almost all of them. But thing is, any code that AI writes, humans have to review because to this day, and probably still for a couple of years at least, AIs hallucinate. And what that means is that sometimes they give an answer that is kind of random garbage and not at all accurate. And so you have to just make sure to review it. And so the ability to understand code is just as important today as it always was and will be for quite a long time, I'm sure. Like the act of writing code itself will probably become less and less popular, but you will still have to figure out how to explain to the AI what you want. And you will still have to have a good enough understanding to check whether it's doing it right or wrong, or maybe it forgot some edge case, like maybe, yeah, just could be some exceptions that it hasn't thought of. Like maybe you're writing a code for a self-driving car, for instance, and maybe it knows how to do everything right unless someone jumps in front of you. And if someone jumps in front of you, maybe it just randomly accelerates and hits the person because of some, let's just say, situation in the code that was not considered. So for things like that, we still need humans in the role. So I would say that learning programming is still very useful and still very necessary. All right. Now, I want to just briefly explain something that's something to think about. So basically, we know that a computer is capable of doing anything that can be specified in steps, and these steps can be any kind of computation. Now, what is computation? Roughly speaking, you don't need to understand exactly what goes on inside the hardware of a computer, but the basic idea is that we manipulate data. Like, for instance, we have some numbers and we want to add them, subtract them, multiply them, divide them, or whatever, and store this in other places, then do some operations on those numbers and store them in other places, and so on. And that alone is enough to create robots, AIs, websites, the internet, and almost everything that we see around us. And one interesting topic is this idea that everything we humans do is probably also computation. Maybe, possibly with the exception of being sentient, like having this awareness that we exist, these feelings. But aside from that, everything that we do is probably carrying out a computation. And what that means is that the neurons in our brain, like our brain is made of neurons, some of them are sensory neurons, which means that they sense things from the environment, like we see things, we hear, we touch, so on. Some of them are motor neurons, so basically ones that allow us to control our hands, our legs, our mouth, and so on. And some of them are interneurons, which is just neurons that connect to neurons. So they don't directly sense or move, but they basically carry out some kind of computation. That's essentially what they are. And these neurons, they communicate to each other by sending signals. And sometimes if one neuron sends a signal to another, this forces this neuron to also send signals to the third one. But sometimes the situation might be the other way around. Like maybe by default, this neuron was already sending signals to this one, but as soon as this one activates and starts sending the signals to this one, that blocks him, and now no one sends the signals to this one. And because of constructions like that, our mind, our brain is capable of carrying out computations. And so, in that sense, probably everything that we do, including things like understanding humor, understanding intentions, looking at someone and figuring out, oh, she must be sad, or he must be angry, or he must be happy. All of these are probably computations. And because they are computations, and because computers also do computations, essentially everything a human do, a computer also can do. Most likely for everything. There might be some exceptions like feelings and such. We don't know for sure if computers can really deeply feel. We don't know how to even check that. But aside from that, yeah, every action that we carry out, every job that we do, computers can also do. And this is very important for AI because generally we can only directly code for things that we understand. But a lot of the things we humans do, we don't actually deeply understand. A very simple example of this is that I can take this finger and bring it to the camera, but I don't actually deeply know how I'm doing this. And here's what I mean. When I did this, look how many muscles I was controlling for that. I was controlling my shoulder, I was controlling my elbow, I was controlling my forearm, I was controlling my wrist to spin it correctly, and even on my finger, I was controlling this angle, this angle, this angle, and together they brought it here. But I'm not actually consciously telling myself, "Oh, let's move this 10 degrees up, this 5 degrees down." I'm not doing that. This is kind of in my intuition. So I'm not conscious of this. And because I'm not conscious of this, I can't just write down the exact steps of how to do this. Like, oh, first move this 5 degrees up, then move this 6 degrees down. I don't know that. So that is why sometimes we are limited in programming because even though we can do something, we don't know how to explain to a computer how to do it. And that is where the field of AI enters, because with AI, we can just basically give a computer a bunch of examples, and from these examples it can figure out, oh, this must be the logic of how it's done, and then it can also do it. This is a very strange feature, and I'll get more into it in our last lecture. But for now, I'm just overviewing. Like in programming, we can only do things that we can figure out how to write down in steps. But however, one of the things that we know how to do is how to create an AI. Basically, this is called the field of machine learning, which is that instead of us directly giving the logic to a program, we instead give it rules for how it can figure out the logic. Like, for example, how to play chess. Maybe you don't actually know how to play chess, but you know what a losing chessboard or winning chessboard looks like. And what you can do is you can just, for instance, make a computer play by itself and just tell it to memorize which moves led to a win, which moves led to losing a figure or winning a figure, and then ask it to just figure out the rules from there. That's roughly what AI and machine learning is. So it's still a kind of programming, but it's like you are programming something that will learn the logic. But for the most part, we are writing the logic directly. So for now, for our lectures, we'll focus on just directly creating the logics. And these logics that will let us basically carry out any kind of computation will build on some very simple building blocks. So we'll now go into the code and I'll just explain what this simple building blocks will look like. And just one thing to consider. You might notice that at first it takes time before these ideas click in your intuition, and this is completely normal. In fact, the way you're supposed to learn programming is that you're supposed to hear an idea or read about an idea, but then you're supposed to go out and practice it with some problems. And so I will be giving you homeworks every week, and I want you to spend as much time on it as you can. Like some of the later tasks in homeworks will be optional because they might be too hard to complete fully, but I still want you to try as much as you can. And I want you to know exactly where you are stuck, not just general, I am stuck, but like, I am stuck on this part. Like, I can't figure out what to do in this step. That's what I want you to try to get. So that at least you know exactly what's not working. Because that's one of the main skills to develop. Okay, so just one thing I want to mention is that in programming, it's not only about writing the code. You have to write the code, yes, but you also have to think about what logic you are creating. And you also have to think about how will you make sure that there are no edge cases you didn't miss. So you have to think hard about what edge cases might exist and just make sure that you test for them and to just, yeah, basically make sense out of it. So some of the important skills that a programmer needs to acquire are the ability to write code, the ability to figure out what logic needs to be done here, the ability to look at code, maybe your code or maybe someone else's code, and figure out what's going on and what might be wrong. And even to just learn, oh, this is new. I didn't know that. Let me just pick that up and use it in future. So these are the skills that we'll try to pick up over time. And yeah, we'll see how it goes. Okay, with that, let's jump into writing our first Python code and we'll figure it out from there. Okay, first of all, do you see my Visual Studio Code screen right now?
Not yet.
No.
That makes sense. 1 second.
No.
How about now?
It is loading.
Yes.
Yes.
Now I see it.
Okay, good. I'll just keep this chat in here. Okay. Okay, so any code that we write is basically instructions that we want our computer to carry out. Now, fundamentally, our computer only knows things like add these numbers, multiply these numbers, and just move the value of this number to a different place and move that value of the number to this place. And so every code that we write is translated. It's called compiling code, but it's same as translating. I'll just write that. Compiling is translating from the programming language of our choice all the way down to machine code. Machine code is just what actually runs on the computer at the end. So there are many different kinds of programming languages. Like there's Java, C++, JavaScript, Python, C, C#, there's a ton. But the thing is, most of them are general purpose languages, which means that any of them could be used for any job. Like you could use any of those languages to write a website. You could use them to, and by the way, our time is about to run out and just re-enter this meeting as soon as it runs out. So yeah, as I was saying, there are many different kinds of programming languages, and any of them can be used to make a game, make a simulation, used for some scientific studies, used to just calculate some, I don't know, multiplication or whatever, can be used to, create websites or analyze some data or even connect to a robot limb and move it, or just any kind of task that can be carried out, any kind of action. Like we can, for example, connect our computer to a device which moves a car or anything. All right. So first of all, do you know what this is? This place that I'm in.
Yeah.
Visual Code Studio.
Yeah. It's Visual Studio Code.
Oh, yeah.
Yeah, Visual Studio is a separate product that's better if you're writing C++ or C# code, but for any other language, this is better. Yeah. So basically, anytime you write code, you have to basically create a file that contains a bunch of text, which is instructions of what to execute. And in theory, you could go hardcore and do that in like Notepad, like just Let's open that to prove my like nothing's stopping you from just opening up Notepad and saying it here. Like let's say I want to print hello world, which is kind of it's kind of a standard of what to begin programming with. And I could just save this file
Recording in
on my
progress.
computer by just saying hello world dot .py. We say dot .py as the type of file when you're writing. Acer, can you disable your microphone?
I'm sorry.
No, no worries. All right, so as I was saying, in theory, nothing's stopping you from just writing your code in Notepad like this and then just saving it on your machine and then just running that code directly. Like I can just open our command prompt, go to where I saved this. I think it's on desktop. Let me see where I saved this actually. There it is. Let me just see where this is. OPS path. So nothing's stopping me from just executing the code like this. And here we'll see that hello world got printed on the screen because that was the instruction that we wrote in here. Like we said, print hello world, which will just, yeah, basically this is a function that Python gives us. We'll dive more deeply into what functions are in later lectures, but basically functions do things for us. Let's just leave it at that for now. And print is a function that prints something to the screen. So when we say print hello world, what that gave us is that when we executed this on our machine by saying Python and then this, we got hello world on our screen. And by the way, by default, if you write Python and then the address of your file, nothing will happen because by default, you won't have Python. So you had to come in here. This is just one of the brain devices. You had to come in here and say Python download, just pretty much just search it up like that. And depending on if you have Windows or Mac or Linux or whatever you have, you'll just find some pretty simple instructions for how to download Python. And then you'll be able to, basically run Python code like this. So when you say Python and then this, just whatever you wrote gets executed. That's simple. So like if I were to say now print counting to 5, 1, 2, 3, 4, 5, let's say, and whatever I want to say, right? I would save this. And now if I re-execute this, you see, hello world, counting to 5, right? So basically any code that we write, we can then execute like this. But it's not very comfortable or logical to write code like this because this is just Notepad. I will have to then close it and come back here and run the code myself every time. That's one downside. The other downside is that if I misspell something, like say I forget to close this here, if I don't do that, this is an error, but I won't know until I run the code. See? Here I know I have a syntax error, unterminated string English, because if you open it up with this, you have to close it as well, so that it knows that that's a piece of text you want to print. So these are the things that I won't be notified about if I do it in Notepad. And also, I won't get any auto-completion or suggestions or just anything, because there's nothing intelligent going on here. I'm just writing in a file. Now, to prevent that, we use what's called integrated development environments. Basically, places that are better than Notepad and can actually help with running the code, looking at the code, figuring out what's wrong with the code, and just making sense of it better. One such place that is one of the, or maybe even the most popular in the world is Visual Studio Code. So it's an open source product from Microsoft. And basically it kind of acts the same as Notepad, I guess, but it's way smarter and way better and more comfortable. Here, we'll see what that means in just a second. So let's do just the equivalent of that over here. So let's say in here, I already have it opened for a folder, but if you wanted to open it for a folder, you would just say open folder, and whatever folder you want, that's where you would work. So let's say I want to create a file. I have to call it something. So let's also just call it hello world.py. This .py is important so that it knows that I'm writing Python code and not some other language. And by the way, if you learn one language, it's very easy to learn any new one because you already, from learning that one language, you already understood the main ideas in programming, like the ideas of variables, printing to the screen, data types, functions, loops, conditionals, and everything, all of which we will go through in the next lectures. So don't worry too much about, wait, which language am I supposed to learn first? It doesn't matter. You'll learn all of them, and knowing one will translate to very quickly learning any other one. So we're starting with Python because, first of all, it's probably the easiest language to learn. And second, because most of the scientific researches, data sciences, AIs, neuroscience, pretty much almost all of those things use Python, simply because it's easiest language to work with. Because unlike many other languages, you don't have to write too much stuff. Here you can just get straight to the point. Like I want to print something to the screen, I just say print. I can say it like this, hello, or I could also say it like this. Like you can see, I can choose this kinds of text markers or this kind of text markers. But if I just write print hello directly, this is an error, because then it will think that hello must be the name of something, some variable or something, and it's not, it's just text. And so in order for it to know that it's text, we have to encase it with either these things or these things. Alternatively, there is also these. For some reason, it doesn't work this time. Okay, I'll see why. But yeah, generally, these two you can stick with. Doesn't matter which one you use, they are interchangeable. I mean, you can't say it like this, so like you can't open with one and close with the other. You have to use same on both sides. That's the only rule. And so this is text. Now, for a moment, like here's what's going on. Like I wrote these things, and just like that, I'll click run here. And I'll see here my result, like hello, hello, hello. And here you can see it all did the same thing as we did, like Python, don't worry about this. And then just the path of where this file is. So users, Marion OneDrive, desktop, neuroscience, SynapseCode, static holdings, hello world.py. So this, writing it here and just clicking on run, is the equivalent of when we wrote it in Notepad and then opened up command prompt and then wrote this ourselves. Let's just close now. So this is just more comfortable. And also, if you notice, it makes comprehension much easier because, for instance, right here, you can see the print is kind of yellowish. Then this is kind of, I guess, orange reddish, so that different types of data get different colors so you can quickly tell what's going on. Like if all of it was white, like it was in Notepad, it'll be much harder to tell what's happening. Okay. Now I want to take a second to introduce some of the core ideas. So this for now is just print. And this, for instance, is the idea of a comment. A comment is ignored. So comment is just something you write for yourself, not for the machine. So generally, all the code you write is for your computer because you run this and your computer figures out, oh, he wants me to print something to the screen, or he wants me to do this, or he wants me to do that. What's his problem? Okay, I'm not sure why that was a problem, but yeah. I'll investigate why that was a problem. But yeah. Basically, any code that you write like this is a comment, and it will be ignored. You can do what you want with it. Not so you can write here, like if I say print hello again, this will not print because it's inside a comment, so it will be ignored. You can see here nothing happened. But if I uncomment it, that is, I remove this sign, hashtag sign, then suddenly it will work. So the main ideas. With print, we put something on the screen. Print puts print. Let's say put something on screen. And then we print something. So we print something on the screen. Print puts print. Let's say put something on screen. Print puts print. Let's say put something on screen. Print puts print. Let's say put something on screen. Print puts print. Let's say put something on screen. Let's say put something on screen. comments use this and are ignored. Like nothing happens for this. And now let's move on to some of the other ideas as well that together build up to a computer that can do anything. Let's see. So, first of all, these are texts, but sometimes we need to work with numbers. Sometimes we need to work with texts. And so we need to work with different kinds of information or data. And for that, there's the idea of data types. So data types mean what kinds of data exist. Like for instance, in Python, we have, roughly speaking, let's say we have text, such as this. We have numbers, like maybe 100, 200, whatever. And actually in Python, we have two kinds of numbers. One is integer numbers, so just whole numbers. And one is floats, which is just like 2.5 or 3.7. Also, we have booleans and arrays and other things as well. And step by step, we'll go through all of them. So let's see. What kinds of data types do we have in Python? In fact, let's just directly print them to the screen. So this 1, 2, 3, let's say this is a number, but it's an integer. It's called an integer because it's a whole number. We could also say like, yeah, 3.14, for instance. This is called a float. It's float because it's floating point, because like this point can go anywhere. I mean, there's a reason for this is because of binary logic in our computers. We don't need to care about that. Just remember, float means that it might be a number that has some things after the dot. So like 3.5, 4.6, whatever. There is also, of course, text, as we encountered before. And as you can tell, we can also write numbers in here, but this is not a number. This is still text. So text in quotes, yep. So one thing to keep in mind is that, like for instance, 1 is not same as text version of 1. Like this is the numeric value of 1, and this is just text version of 1. And these are different because sometimes you want them to be perceived as numbers that can be added, multiplied, whatever. Sometimes you just want them to be a part of a name or part of a word. So you might sometimes have to turn this into a text, or you might have to sometimes turn this text into a number. Let me see what was in the chat. Etna, Visual Studio Code should be able to open on your computer regardless. But yeah, by the way, you don't have to use Visual Studio Code. There are alternatives like PyCharm, Sublime, and a bunch of others. But I recommend Visual Studio Code because it's, in my opinion, the most comfortable and easiest to set up and use. But it doesn't matter which one you use. You could even write the code in Notepad and then compile it, or you could even be ultimately lazy. And here's what you could do. Yeah, sure thing. Anything goes, basically, for where to put code. Like you could even write it online and maybe just send a link or screenshot or something. Like you can just say Python online IDE. Here, online Python. Here you can just write your code here and run it here directly. Like let's say print hi. Now I want to say hi. I run it, and on this side I get hi. Like I don't really care too much where you write your code, wherever you prefer. But you should be able to put Visual Studio Code on your computer. I'll link you some installation tutorials, and if after those it's still a problem, then we can talk directly after the lecture anytime, and I can help you with it. But yeah, I mean, basically, you can even just say Python online editor. Just Google it. You'll find this onlinepython.com. Let me just copy that as well. And you can use that as well. So I don't care where you write your code. Do it wherever you prefer, wherever is comfortable. I just like VS Code most, so it's the one that I use. Visual Studio Code, VS Code, same thing. Yeah. Okay, so what kinds of values do we have? We have numbers of two kinds. There's integers and floats. We have text values, and it doesn't matter if, like in some programming languages, one letter is called a character and multiple letters is called a string. But in Python, even if it's only one letter, it's still a string. Like if I were to say print H, still a string. I guess it's still a string. Python also has some other things. Another thing it has is a Boolean. A Boolean is basically true or false. So basically you can say true, or you can say false. Let me just make a special case for that. Booleans. Yeah, true or false. And this is useful because sometimes you'll say 3 is more than 5, or 4 is less than 9, things like that. So we know that this statement is false, so this will be the equivalent of writing false, and this is the equivalent of writing true. The goal with this is that eventually we'll have variables for which at first we won't know which side is true, and depending on if one side is more or one side is less, we might want to execute different parts of code. So like the entire purpose of Booleans is that with them you can do some conditional logics. Like you can say, for instance, suppose you're writing code for an automatic bar and somebody comes in and they want to buy some drinks, let's say. You can say if age is more than 18, just go ahead with it. But if age is less than 18, then print no, you can't drink because you're a minor. So that kind of things is where it's useful, and we'll get into that in just a moment. But basically, this is what a Boolean is. Let me just give you a couple more examples of what that might look like. We can also check the equality of things. Like we can say, is 2 plus 2 equal to 4? You know that in mathematics you would say it like this, but in programming, in almost every programming language, this is the assignment operator. We'll get into that in a bit. But for checking the equality, we say it like this. So double equal sign. So when I say 2 plus 2 equal 4, what I'm saying is it true that 2 plus 2 is 4? So this will either be true or false. I mean, in this case, we know it's true, but let's say a more complicated case where it might not be so obvious from the start whether it's true or not. Like, is this true or false? I don't know, probably not. 3, 10, yeah, it's not true. So let's see what we get on the screen. We got 8, we got true, you can see. We got false. 3 more than 5 is false. 4 less than 9 is true. 2 plus 2 equals 4 is true. And this thing equals 6 is false. So basically we can say just directly true or false, or we can just say, is this more than that? Is this less than that? Are these equal? Now let's see some few other things we can check. We can also see, is 3 more than or equal to 2? So this is more than or equal. It's the same as saying more or equal. Yeah, you get the idea. We can also say, is 4 less than or equal to 1? Of course, it's not. Like, is 4 less than or equal to 4? Which it is, of course. We can also say things like not equal. Like, let's say 5 not equal to plus 2. This is true because 5 is indeed not equal. But if I say 5 not equal 4 plus 1 or 6 not equal 6, these are false statements because, of course, 5 is equal to 5. You get the idea. Okay. Now, by the way, at any point, feel free to stop me. Feel free to ask any questions in the chat or just to say it. And yeah, we'll just go through them. I'll just go through the main fundamental principles. I won't dive too deeply because our lecture is already too long right now. But I will give you some homeworks that will challenge you a little bit, not too much, a little bit to look things up yourself and to figure some things out. So, okay, so this point, let me just show it here. If I ask, is 1 equal to 1? You see, this is false. But if I ask, is 1 equal to 1, that will be true. As you can see, this is true, but this is false. Because text and number are not the same things, basically. All right. Let me think if I remembered. Oh, yeah. One more thing. When we are constructing statements that are either true or false, we're not limited to this. Another thing we can do is we can make them more complicated by saying words like and or not. Let's see examples. In fact, let's comment this out so that our output is not too cluttered. I'll just comment these ones out. This ones as well, I guess. It's fine. By the way, what I'm doing is I'm marking whichever lines I want, and then I'm clicking Control/. Like this is how I comment chosen lines. Different editor environments have different shortcuts. Some even don't have them. For Visual Studio Code, it's Control/. It's actually very common, but some environments might have different ones. Like this one on the web, maybe doesn't even have it. Oh, it does. Oh, good. But like Notepad would not have it. Okay, so let me just go into more complicated examples of statements. Like I might say, let's say I want to check that, let's say quickly, let me just introduce the idea of variables to get you used to it. So for now, everything was being written directly in here. But what if we want to make sense of these numbers? Like in the real world, for example, in the case of a bar, maybe I want to know that I am comparing the age and not just some numbers. So let's see what that would look like. Like let's say we are in a bar. Like, I don't know, welcome to our bar, to the bar, right? We'll just write that to the screen. Obviously, this is nothing. We're just writing text to the screen. But yeah, now let's say that age is 16, for instance. And here I want to say, yeah, okay, that was a good idea from Python. We can print this age to the screen. Like, here's what will happen. We get 16 on the screen. If I print it like this, of course, I would get the word age itself. But when I print it like this, it will give me whatever value is stored inside this variable of age. In this case, this variable of age is storing 16. So when I run this, yeah, see, I got 16. All right. Now, let's make it a little bit more complicated. Let's say you can only drink alcohol if you are more than 18 years old. So we can say a variable called can drink alcohol. And by the way, in Python, it's common that when you have multiple words in a variable name, you should separate them with the underscore. This is called snake casing. There are many different kinds of conventions generally, but yeah, I'll just go through them all. So what I would say is age must be more than or equal to 18. By the way, writing it like this is the same as writing it like this. I'm just writing it like this to make sure that you don't get confused. So yeah, just like that. So in this case, if I print can drink alcohol, it will say false. See, it said false because I can't drink alcohol because, yeah, my age is not more than or equal to 18. But if I were to say age is 26, now it will say true. So basically what this allows is that we can build up logics for anything. Ultimately, this means literally anything, like even logics of how to create an autonomous scientist or someone who can go out into the world and do things like with robots, or just someone who can play games through the code. Like we can essentially create artificial creatures if we push it far enough, like they do in video games. Like for example, let's say in GTA games, you can interact with people, you can fight them and such, and they can fight back. That's because those people have some source code running that lets them just act because of this. So basically, with this simple constructions, we can eventually do everything. So let's just take a couple more examples of variables. It can also be like name. Let's say my name is Nika. And I can just print the name here. And now let's do a complicated example. In print, we can just couple things. Like we can say Nika is age, years old, and it is, let's say, can drink alcohol, that he can drink. So this together, but let me just move this here. Let me just, yeah. So all of this together will write to the screen. Nika is, in this case, 26 years old. I'm not 26, but yeah. And it is, in this case, true, but he can drink. So let's see what that looks like on the screen. See, it says Nika is 26 years old, and it is true that he can drink. If I change anything here, like let's say instead of Nika, it's Gio now, it will say Gio is 26 years old, and it is true that he can drink. Or if I say that now age requirement became 180, for instance, now Gio is 26 years old, and it is false that he can drink. So basically, just like that, we can construct a program that will, for example, be able to tell whether or not anyone can drink. Let me just make it a little bit more complicated again now. This time, let's write a program that doesn't work with a given age and name, but instead asks the user, hey, what's your name and how old are you? And then it'll tell us this. So for now, every value that we assign to these variables, we assign by hand directly. But if we want a program which on every run can just let us right from here give the name and age, we need to use some new thing from Python we haven't encountered yet, and that thing is called input. Let's see what that looks like. Say I want to get name. So like last time I just said name equals Gio, for instance, right? This time, because I want this to change on every run, I will say name equals input. What is your name? Let's see what this does and just print it on the screen. Let's say you are name. Let's just see what this looks like. I run the code and I get here. What is your name? And see, it's waiting for me right here because of his input. And when I say some name, like I can even say some. Oh, yeah, sorry. Hold up. Yeah, right here. In our terminal, it says, hello, what is your name? I can say some random nonsense word, and it'll tell me you are in that word. So this input function allows us to ask a question or say something, and then take the input from the user. In this case, let's build that up into this logic for any person. So here we'll now take age as well. How old are you? I'm leaving the space so that there's a room here before I start writing. And for now, let's say, and you are age, years old. So what is your name? Nika. I am 22 is my real age. And so we say you are Nika and you are 22 years old. So just like that, we can construct logic. Now let's say that we want to bring back this can drink alcohol logic. Now, one problem right now is that I can't just directly compare this to a number because this is text. Even though it's 22, it's this kind of 22 instead of this kind of 22. So in order to go from this kind of 22 to this kind of 22, we need to use int. Let's see what that looks like. So we want to say that age is actually int age. And this means that before this, age was text version of 22, and now it's an integer version of 22. So now it's a number. And now that it's a number, I can just say, can drink alcohol equals just age is more than equal to 18, just as we had before. And we can say, and it is can drink alcohol, that you can drink alcohol. And so just like that, what we created here allows us to ask for the name, like we say, Luca, 5 years old. You are Luca, you're 5 years old, and it is false that you can drink alcohol. Yeah, you can't. Now let's run it again. And this time, if I say, I don't know, Katie, let's say 24 years old, you are Katie, you are 24 years old, and it is true that you can drink alcohol. Or maybe instead of saying it is true that or it is false that, we want a more complicated message. Like maybe we want to say something like you can't drink or you can drink. So maybe we want to customize it. In that case, let's comment this one out. Let's introduce one more idea for this lecture. This is an idea of if statement. I think we can do that in 1 minute very well. So let's see. If can drink alcohol. So if I can drink alcohol, and this is the entire purpose of Booleans, by the way, this true or false statements. The entire purpose of Booleans is that they allow us to write if statements and loops. So we say if can drink alcohol, print you are name, you are 8 years old, and you can drink alcohol. Or else we'll say you are too young. And so now, when I run this, if I say Gio 3 years old, it says you are too young. But if I say Lasha 30 years old, it says you are Lasha, you're 30 years old and you can drink alcohol. I will send this code in our Discord group. If anyone is not in the Discord group, text me or ask Nini and we'll add you to the group, of course. And these are the main basic ideas for now.